All right, so for this video, it's going to review that little problem we did in class about latitude and longitude. So if I pick a couple of cities, let's say I do Toronto, and I don't know, Cairo or something, okay? I can go online here and find their latitudes and longitudes. Notice that I did one in Toronto, which is clearly in the eastern. It would have eastern latitude and longitudes, or longitudes, I should say. Toronto latitude, longitude, 43.65, 43.65 north. By the way, that's further south than we currently are in Wilsonville when we're meeting in class, and then 79 degrees. 79 degrees. Did I say east? I meant west. 79 degrees. 79.38 degrees. West longitude, if you will. And then for Cairo, still in the north latitude, but not by a whole bunch. Probably about, 10 degrees, I think? 15? Oh, geez, it's 30 degrees. 30 degrees. 30 degrees north. And 31.2 degrees east. Okay, so remember, the thing to keep in mind is that zero longitude runs right through London. Well, technically just a little outside London, but again, why would you put it there? I don't know, because that's where you're the guy who's doing it. I'm going to put it where I'm at because it's convenient. Okay, so whatever. So when we go from these guys, we need to convert these because these are not spherical coordinates, so we can make them spherical coordinates. So both of them are roughly 4,000 miles from the center of the Earth. Our longitude is our theta, and you could do it a couple of different ways. You could start here and go around to the east to 180 like so. We could do that. If we did that, you'd be like, well, wait. So you go all the way around like this, right? And then, of course, that would put this at like 280 degrees roughly all the way around to Toronto. You could do that, or you could just say the easy way, 79.38. And then, of course, Cairo is going to be 4,000 negative 31.2. That works because the math's the same way, as the kids say. And then theta, phi is from the North Pole down, like so. So it's going to be phi is equal to 90 minus the latitude. Okay? So that's going to be 90 minus 43.65. So about 46.35 here. And then 90 minus 30 is 60 degrees here. Okay, boom, 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 and boom. Okay, so what we have is we've now converted all this stuff to the actual, what's the word I'm looking for? Spherical coordinates. Now, we need to convert these guys to rectangular coordinates. So the formula goes something like this. Remember, it's 4,000. So rho times the cosine of theta. So our theta here is 79.38 times the sine of 46.35. And I get 533. That's my x value, comma, and then I need my y. So the only difference between those two is it's going to be the sine of 79. Boom. And you get 2844. And then the next one is, so 4,000, remember, cosine of 46.35. So that is rho cosine phi. And you get 2761. Remember, this squared, that better be 4,000 roughly, right? So you always check yourself, 533 squared plus 2844 squared plus 2761 squared. Square rooted is... All right. Oops. Well, it's helpful if that middle one was squared, stupid. So come back up here. Let's try that again. Maybe if you get a caret in there, it might actually work this time, Jay. There you go, stupid. Do the 0.5. Look at that. 4,000 on this snob. Yeah, so we're probably right. I mean, you could have still screwed it up. It's unlikely, but it's possible, you know. All right, so then 4,000 cosine of our theta down here, so negative 31.2, comma, or not comma, times the sine of 60, boom, is 2963. And then change that first cosine there to a sine now. And then negative 1794. That's not surprising. We went the other way around the planet, so that makes sense. We're going to have at least some negative. My z's, of course, will all be positive because we're in the northern hemisphere. Times the cosine of 60, and you get 2,000. Again, you could check yourself, but I feel fairly confident. Here's the game. Any two cities will be drawn such that you could... What in the Sam Hill's going on? Any two cities can be drawn such that there is a circle that can be cut out that goes between the two of them. And this is an arc length. Boom, boom. This is a vector from 0, 0, 0, 0, 0, 0 to each of the cities, which means this, which is a point, becomes a vector. 5, 3, 3, 2, 8, 4, 4, 2, 7, 6, 1 vector to Toronto, and 2963, comma, negative 1794, comma, 2000. It was the one to Cairo. Okay, well, that's cute and all. So then what do I want to do with that? Well, in order to do this, I need to find theta. Oh, not phi, stupid. I need to find theta, if you will. We always refer to that as theta. Let's call it a different angle. Let's refer to it as gamma. We need to find that angle, the angle between them. And so to do that, of course, you need to find the dot product. So you recall the cosine of gamma in this case is equal to A dot B over the magnitude of A times the magnitude of B. Now, these are both 4,000, right? So 4,000 squared on the bottom. And I simply need to do the dot product. Now, I could take the time to type them in. That seems like a lot of work. So I'm just going to go 533 times 2963 plus 2844 times negative 1795, well, 94, I'm sorry, plus 2761 times 2000. Look at that, divided by 4,000 squared. Well, poop. All right, let's get it. Oh, darn it. Darn it. Clear. Go grab that. Dun, dun, dun. We get 0.12. That's the cosine. So arc cosine of this fella is equal to this. So about 82.8 degrees. Now what we're saying here is this. The circumference of the Earth would be pi times the diameter of the Earth, so roughly 8,000 miles, times 82.5 or 82.8 divided by 360. It's a part of the circumference. So 8,000 times pi, as you know, is about 24,000 miles, which is about the circumference of the Earth, times 82.8 divided by 360 is about 5780 miles between these two cities. Now, what a guy can do then is come back in here and go to Great Circle Mapper, which is a pretty cool tool. Great Circle Mapper, that guy right there. And now I picked 2 points on the circle, so I'm going to do Toronto Airport Code. And we need that for this thing, so YYZ. Where did it go? Great Circle. Oh, for crying in the mud. Where did it go? I guess this one maybe. Oh, yep, this is the one. Yep. Yep. They just changed it. So all I need to do is I need to put in YYZ 2, and then we need to go Cairo. And CAI, of course, CAI. And enter 2 more airports to draw a line between them. I'm sorry. I see what you have to do. You don't just do. There you go. Cool. And go. How exciting. Boom. Go. There it is, baby. And it's 92.48 kilometers. Well, that's useless. We're America. America. 57.80, baby. Let me tell you right now, we a little overshot it. Guess what? I probably figured out as I go shooting by. We missed the pyramids, fellers. Turn around. We a little overshot there, okay? Again, if I wanted to know the actual distance, probably wouldn't be doing it this way. I'd probably, have written an actual program, takes it out to the gazillionth decimal place, all that good stuff. All right, cool. This is no big deal. Looks like we fly part of the rest of Canada, open ocean. We shoot across the central part of Europe. Notice we didn't fly over any active war zones. Clearly, if we'd gone to, India or somewhere, oh, look, we're flying right over Ukraine. That's probably not optimal. So, this is the shortest distance, the Great Circle Route. In the real world, sometimes you have to take the circuitous route to avoid, things like getting shot down, etc.